Hello, my name is Tom McDermott, and this is part 3 of a video series Getting Started with KA9Q Radio. In this video, we'll look at decoding digital signals, WSPR, the weak signal propagation reporting signal, as well as FT4 and FT8. The configuration is similar to the previous two videos. We have a server which is using a Raspberry Pi or other Linux computer, and attached to that is an RX888 dongle and an HF receiver antenna. The antenna is a active loop antenna. We will access this computer using SSH over Ethernet, and we'll bring up KA9Q radio, which has been installed on this server computer. On the client computer, we are running Linux, and we may run GNU radio. For this demonstration, we're not. We'll access it via a terminal window, and on that computer, we have installed KA9Q radio, and also another software package called FT8_lib. This package allows us to decode FT4 and FT8. We also have an Ethernet switch, and we'll demonstrate the 3 separate decoders. This is a block diagram. On the left, you can see a small wideband HF receive loop antenna powered by a bias T, and that's connected to an RX888 receiver. That receiver is plugged into the USB port on a Raspberry Pi or Linux PC, which can be headless. In this demonstration, it is a headless computer, meaning it doesn't have a keyboard, mouse, or a monitor. That is connected through an Ethernet switch to our client PC, which is a Linux PC, which does have a display, keyboard, and mouse. The computers all use DHCP, so their IP addresses are assigned dynamically. We use gigabit Ethernet cables. Don't use Wi-Fi, as it doesn't behave too well with multicast. The software sources: Phil Karn's KA9Q radio is on his GitHub site at KA9Q/KA9Q-radio, and FT8_lib, which is also on Phil's GitHub site in a different repository, KA9Q/FT8_lib. The tutorial support files are located on my GitHub, tom-mcdermott/miscellaneous. Parts 1 and 2 go into installation and recommendation and other references. You may wish to refer to those if you haven't seen them. And additionally, for FT8 and FT4, we have to clone the FT8 library, then do a make and a sudo make install from Phil's separate repository. This is some snippets from the RX888-KA9Q-HF.conf file. The 3 sections we're interested in: the first is WSPR, and what that does is to demodulate using an upper sideband audio demodulator various different frequency bands in the HF range. There is a separate set of decoders for FT4, which decode a different set of bands, also in the HF range. And then a third section, FT8, which decode another set of upper sideband audio band segments. Each of these produces a different data stream: whisper-pcm.local for the whisper data stream containing the whisper audio, FT4-pcm.local for the FT4 PCM audio streams for each band, and then FT8-pcm.local for the FT8 audio streams. There is some preliminary one-time setup needed to make these demodulators work. At the root of your file system, you need to create a directory to hold the wave recordings. So you need to create /recordings. Since this is at the root of the file system, this directory is owned by root, and so you need to use sudo to make that directory. You'll also need to create subdirectories for each mode, again using sudo. In the /recordings directory, you'll need to create WSPR and also FT4 and FT8. Those three subdirectories need to have the ownership and file mode changed after creation. So here on my system, you can see that recordings is owned by root, and then recordings/FT8 needs to be owned by recordings:radio. FT8 needs to have an ownership of recordings:radio, and Whisper needs an ownership of recordings:radio. You also should set the file mode properties for 777 on each of those three subdirectories. Once you've created those subdirectories, then you will be able to get started. In this example, we're going to run the decoders as a service. In general, the syntax for starting a service is to change to KA9Q/radio/service, and then once in the KA9Q radio/service directory, you'll need to sudo systemctl start and the service name. Start starts a service, but it does not make it run at boot time. To make a service run at boot time, you'll use the enable and disable commands, which affect the boot time behavior. You can use sudo system control status and the service name, and sudo system control stop and the service name. Status will tell you the status of the service, and stop will stop the service. The decoder output is a little bit different. Whisper generates in /recordings/whisper a number of different directories, one for each band. In each band, you'll find a spot file, which is just the spots created during the most recent 2-minute time slot, plus an all text file, which continues to append all the Whisper spots for all the different file time slots, and then the other miscellaneous files. FT4 and FT8 append to /var/log ft4.log and ft8.log respectively with newly accumulated spots, so the log files will continue to collect spots over a long period of time. In Demo 1, we'll record Whisper signals. We'll decode signals on all of the HF Whisper bands simultaneously. All the bands are decoded over a 2-minute time period. Each band is recorded for 2 minutes as a WAV file, and then after the signals are decoded, the individual WAV files for each band are deleted. It creates a spot file, just the transmitting stations for that 2-minute period, and it concatenates all text to the all text file per band. The Whisper service does not upload spots. Every 2 minutes when you've gotten a file, you'll need to upload that file separately to a spot collector. The decoders are computationally intensive. The Raspberry Pi on the radio would have difficulty running both KA9Q radio and Whisper decoder. So in this demo, we will run KA9Q radio only on the server computer, and we'll run Whisper decoder on the client computer. And the client computer in this case is a bit more powerful of a computer than a Raspberry Pi is as the server. For demonstration number 1, we will bring up KA9Q radio on the server computer using SSH, and then we'll open a window on the client computer, and we will invoke the service that starts up the Whisper decoder. So first of all, we'll SSH into the server. And we need to change to the KA9Q radio directory. And then we will invoke the Radio D daemon and bring up the Radio D HF configuration file, which has data streams for WSPR, FT4, and FT8, as well as others, but we won't be using those in this demo. And here we can see we have an FT8 data stream, a WSPR data stream, and an FT4 data stream. We'll now close down this window and bring open another window. And we will change the KA9Q radio and then to the service directory. And we will start the WSPR daemon server. And that's about it for all that we see. The service is now running in the background, and it runs on about a 2-minute cycle. So it'll take just a little while before we start to see output. We'll change to the recordings WSPR directory. And we can see now that we have a directory for every band of interest. We'll let this run for a little bit of time, and then we'll go in and take a look at one of those band segments. So we'll change to the 20-meter band, and we can see that we have a number of files created. If we look at the WSPR spots file, we can see that we've recorded several different WSPR spots. Again, this is the file that changes every 2 minutes. And so if you don't capture this on a 2-minute basis, it'll be lost and replaced by the next 2-minute file. So if you're going to actually upload spots, you have to yank this file out with some kind of a programmatic method and upload it to a spot system. There is a package called WSPR daemon that Rob Robinette has that will do this whole process separately for uploading to the WSPR daemon. We can also look at the all WSPR spots file. Let's open the window a little bit here. And you can see that this is a collection of all of the spots since we started the invocation of the program. And so every 2 minutes, it'll keep appending spots to the file. We'll now stop the service. And that will cause the WSPR daemon decoded service to halt. We can look at the status of it. And we can see that the service is now inactive because it was exited. We forced it to exit by stopping the decoder, and we can see that it is in fact exited. FT4 signals, and then later on FT8 signals. We will decode signals on all of the various FT4 and FT8 HF bands, respectively. These bands are decoded over a bit shorter time period than the WSPR signals. Each band is recorded during the time slot as a WAV file, and the WAV files are deleted after decoding. It uses the KA9Q FT8_lib to decode these signals, and that needs to be installed separately, as we discussed earlier. It concatenates the spots to a log file, so it operates a little bit differently than the WSPR decoder. It creates and deletes the WAV files for each band for each decode period, and it also does not upload spots. That has to be done separately. Again, this is also computationally intensive, and the Raspberry Pi has a little bit of difficulty running both the radio and the decoder, so we have two separate computers, one for the server running the radio and one for the client running the decoder. We will now decode spots on FT4 using the FT4 service decoder. We've changed into the KA9Q radio/service directory, And so we can start this decoder with start sudo system control start ft4-decoded .service. And it will start. Now this is a little different than the Whisper decode as we mentioned earlier, in that all that it does is append spots to the log file. So let's change to /var/log and look at the log file. And here we can see that we've captured a few FT4 spots, and particularly on 40, 20, 17, 15, and 10 meters. And if we continue to wait, we will then collect additional spots as they're decoded. So you can see we've collected a few more additional spots. We can now stop the service by using the system control stop command. Similarly, if we want to decode FT8, we will change to the KA9Q radio service directory, and hopefully we need to change to our home directory first, and then change to the KA9Q radio service. And now we can start that service. And again, we will cd to /var/log, and we will look at the FT8 log file, which contains the FT8 logs. And we can see we've captured a bunch already. FT8's pretty busy, and even a very short period of time will catch a whole lot of spots. Again, if we want to stop this service, we will stop this service thusly. I'd like to thank Phil Karn, KA9Q, for the development of the KA9Q radio and FT8 live software packages, and the HamSci team, the Ham Radio Citizen Science Project, and Dr. Nathaniel Frizzell, W2NAF, who's the project principal investigator.